It can be pretty easy to see why you would want particle effects in your games project. Adding particle systems to your game can add a lot more flash and greatly enhance the user experience. Particle systems in Unity are the way to create these super cool looking particle effects, creating effects from waterfalls to flamethrowers and just about everything in between. They can be applied to your game's environment, weapons, attacks, really just anything to add a bit more visual flair. In this video we'll cover the different aspects of the particle system in Unity. We'll cover a practical example of how to make a particle system, and we'll learn a tiny bit about particle attractors at the very end. So without further ado, let's get to learning about particle systems in Unity. To start off with, a particle system is a component of a game object not unlike everything else in Unity, although generally speaking it's best to keep particle systems on their own game object to modify its transform and active status. They can be modified in the inspector window until your heart's content, and can also be accessed through code like other components to modify their modules and properties. Speaking of modules and properties, let's get into some of the terminology we'll be referring to in this tutorial for the sake of clarity. The component particle system is made up of a series of modules that can be enabled and disabled, each affecting a different element of the system. Modules in themselves are made up from a series of properties that can affect individual particles or the particle emitter. Properties that affect individual particles can change their size, speed, color, and more, while properties that affect the emitter can change the emitter shape, whether looping is required, the emission rate, and so on. The distinction between particles and the emitter is important in order to get a better understanding of how particle systems work, and to avoid future headaches with getting the modules and properties confused. Modules like Emission, Shape, and Renderer you'll find are almost always on, as they are some of the most important modules you'll be working in. Before we get into that, it's important not to neglect the most important module of all, the particle system main module. This module is always enabled from within the component and contains a lot of the basic settings you'll need, both for the emitter and for individual particles. Through it, you can change the emitter duration and looping, as well as particle properties like size, color, and if they're affected by gravity. A lot of properties in the module refer to the size and color as start element. This is because other modules can come into play to affect these different elements over a particle's life cycle, which we will get into later. Properties don't necessarily need to work off basic numerical values. A large amount of properties in different modules can be affected by modifiers that can add randomness to your particles or make them change behaviors through the particle system's duration. Just as a side note, this is where a lot of confusion happens, as it can be easy to get confused with duration and lifetime, which is why the distinction between particles and the emitter is important. Duration references how long the emitter should be going for in seconds, while particle lifetime is how long the particle is alive for. These modifiers can be constant, which is good for just default values, curves, which is good for changing over a lifetime or duration, between two constants, which is good to get randomness, and between two curves, which is a mix of randomness and changing over duration. Involves a lot of math and trial and error to get right, but it can be very useful if you know what you're doing. Before we move on from the main module, simulation space is a noteworthy property to address. It decides whether a particle should be moving with the parent object or if they should be moving independently. This can be paired with the inherent velocity module if you want to apply an emitter's velocity to the particle forces. Moving on to the emission module, it has the responsibility of determining how many particles spawn over a certain period of time. Think of it as rate over time, such as having 20 particles spawn over 1 second. Alternatively, you could use rate over distance, which spawns a number of particles when the parent object moves. The higher the number, the more particles you'll spawn on move. An object that moves around frequently will also spawn more particles. This pairs well with the main module, World Simulation Space property, to create smoke and dust trails. Emission also has burst options that can be used exclusively for particle emission or in unison with the prior emission method. Bursts are useful if you want to spawn a bunch of particles at once or over multiple bursts. Through its properties, you can determine when the burst should start occurring, modify the number of cycles. Modify the intervals to have multiple waves of particles spawn between interval times, and play around with the probability for that little extra randomness. The shape module, like the emission module, is responsible for making changes to the particle emitter. More specifically, and fairly obviously, it determines the shape of the particle emitter. You can choose from a series of meshes or even specify your own mesh. Particles can be chosen to emit from the surface, edge, or face of the mesh. It has properties for position, rotation, and scale like a standard transform. And just because we love randomness in our particles, shooting particles in random directions is also possible, as well as randomizing particle spawn positions, which can even go outside the shape's scale if needed. The renderer is another core module of the particle system and defines the look of individual particles. Here you can select if you want 2D looking particles by selecting billboard, or 3D particles through the use of a mesh. The particle material is set in the module, which by extension also means shader materials can be assigned here to create even cooler looking particle effects. Shadows can be cast and received by particles by enabling the option within this module. Minimum and maximum size of particles can be scaled here. However, be wary that this scaling is in regards to particle size on the viewport, essentially 1 equaling the entire viewport and 0 equaling none of the viewport. Generally speaking, you'll want to modify the particle size in the main module or the size over lifetime module. Unity has a number of modules that change particles and the emitter over lifetime or by speed. For the sake of time, here is a list of the properties that can be affected. They can also be affected through modifiers. The noise module is a particularly interesting module that isn't the easiest to grasp at first. To put it simply, noise creates turbulence, and turbulence is good for randomness. Modifying the noise property creates interesting random effects for particle movement, rotations, and size. Changing noise strength will determine how much the noise should affect the particles. A lower frequency will result in more soft, smooth noise, while a higher frequency will rapidly change the noise. Scroll speed can be used to change the noise over time, which is further visually supported with a noise texture sheet in the module. Increasing octaves will stack multiple noise layers on top of another. However, don't stack too many noise layers as it can decrease performance a fair bit. There's a collision and trigger module in particle systems as well. If you know the difference between collisions and triggers in Unity, then you'll likely know the difference here. Particle collision allows particles to collide with other objects, most commonly in world space. With a lot of particles colliding in world space, it can get expensive, so it's not a bad idea to define a plane of collision to help save performance. Collisions also have properties like dampen and bounce to get your particle collisions looking just right. Triggers, on the other hand, can perform certain tasks on trigger enter or exit, or when they're located inside or outside a specified collider. They can disappear through kill, ignore a collision, or perform an on-particle trigger callback for versatility through scripting. Looking for particle systems to spawn from particles? Through sub-emitters, you can do exactly that, spawn a particle system emitter through a particle. The sub-emitter gets spawned depending on a trigger set by the user in the inspector window. These triggers include on-particle birth, collision, death, trigger interactions, or when called manually through script. Texture sheet animation is an important module to know about if you're looking to animate your particles. You'll see this module commonly used to achieve effects like animated fire. You can use a texture grid or individual sprites of particles to achieve this effect. By setting the time mode, you can decide when you want the particles to go to the next frame, whether it be through the particle's lifetime, speed, or by frames per second. The number of cycles and starting frame can also be modified within the module. You can add lights to your particles through the light module. You can define a suitable lighting type and play around with the variables to affect lighting range, color, and more. The point light seems to be the most commonly used one. A maximum number of lights can be set so that performance drops can be mitigated as a result of too many lighting updates. Trails are not only an effect you can put on game objects, but on particles too, through the Trails module. Trails can be made to spawn off particles through particle mode or between particles through ribbon mode. Trails have many properties that carry over from Unity trails and other particle modules such as size, color, and lifetime. Make sure to set the trail material located within the renderer module to avoid using the pink square texture. Moving on to scripting, particle systems are treated like any other component would in script. It contains many different useful functions like play, pause, and stop, and also makes use of functions to collect data on your current particle system, such as emit to count the number of particles and get custom particle data. Module properties of a particle system can be modified too, but be sure to specify what module you'd like to modify before addressing its property. We'll now get to working on making a custom particle system using some of the modules learnt in this tutorial. We'll also be using some shaders provided from the universal render pipeline to achieve an even greater visual effect, but don't worry, we'll keep it simple and be sure to walk you through the setup.
Now that we've gone over the different features, we can now make some particles. For this demo, we'll be creating the shrine particles that we see when we get the orbs from the Chicote monks. As well, we'll be briefly demonstrating the use of the particle system force field to demonstrate its effects on the particles in your game. In this demo, however, we will only go over the particles and will exclude the semi-transparent glowing cube that is used as the shape of our example shrine. Before we start, we'll be using the universal render pipeline as we'll be using the particle shaders contained in it to make our particle materials. You can do this by opening up the package manager, then either search or select the universal render pipeline from the list, then install. After completing installation, then head over to the project folder, right-click, then head over to the universal render pipeline and select URP pipeline asset forward renderer. From there, you will have a URP asset which you can modify to your liking. From there, head to the project settings, and then in the graphics page, set the custom renderer to the universal render pipeline. Now, if you are using any primitives or objects in the scene before switching render pipelines, select on Edit in your navbar, then select Render Pipeline, Universal Render Pipeline, and upgrade all materials to URP. From there, your scene is now set up to use the Universal Render Pipeline and the many different assets and shaders that we'll be using to create our materials. So firstly, create an empty game object or primitive, as that will contain the particle systems we'll be using to create our effect. Before we start, I've prepared myself an emissive unlit shader I've made using ShaderGraph. However, as we won't be going into ShaderGraph in this demo, you can just make a simple unlit blue material or stick with the default material. Firstly, add the particle systems under that game object and call it primary emitter. This will be the particles to create the multitude of line particles we see in Breath of the Wild. Firstly, what we want is for our particles to be emitted from a cube shape. We do this inside the Shape tab. Set the shape to box and set the emit from to shell from the dropdown. Next, we scale the shape to any desired size you want. However, for this case, it will be scaled equally to 6 to have a cube shape. But make sure to set your object scale with the particle system to 1. Lastly, we set the spherical direction to 1, and from there we can see that our particles are now beginning to be emitted from the cube shape. Once we get that going, we will set up the basic particles. Firstly, we will set up the lifetime to be random between two constants, 5 and 7, and set the speed likewise to 2 and 10. That way, the particles can last and travel at the values specified respectively. Next, we vary the start size between 0.5 and 1 and enable the 3D start rotation. From there, we set the particles to rotate to 0 to 360 on all axes. That way, the particles have a varying particle rotation on emission. Now that we have the attributes that make up the particles, we need to fix up the emission so that it doesn't emit over time. Under the Emissions tab, set the rate over time to 0 and add in a burst. From there, you can set the particle count to anything over 500. Now that we got it somewhat behaving as the end result, it certainly doesn't look like it. From here, we will make a particle material. First, we will make a shrine bar particle. In your projects window, create a new material, and from there, click on the shader dropdown. Select Universal Render Pipeline, and then select on Particles, then Unlit. From there, we set the surface type to transparent, blending mode to additive, and color mode to multiply. This is so that the materials can have a transparent background during emission. From there, we select the shrine bar texture which I've made in Photoshop and place them in both base map and emission. And if you download the link to the public Git project, then you have access to these custom maps which I've made in Photoshop. Under the emission map, you can then select the color drop and choose a bluish color. From there, ensure that you set the intensity to 2.5 so that in post-processing, these particles will glow. But we'll visit that later on. From here, you head back to the particle system and scroll right to the bottom where you open the Renderers tab. Replace the already existing default material and add in the new shrine bar material. Now when playing the particle effect, you should see the expected bars that emit away from the cube. However, we can do more. Firstly, open the velocity over lifetime and change the speed modifier to utilize a random between two curves. With the two curves, set the first one to use a gradual decline Bezier curve, with the second taking a much sharper decline curve. This is so that the particles can slow at different rates. Additionally, we'd want the particles to fade over time. So in the Particles tab, click the drop-down and select the random between two gradients. From there, you'd want to click just above the color preview to make another marker, and then select the last marker and reduce the alpha to 0 to make it transparent. Do this as well for the other gradient, but ensure that the alpha value is not the same, so that the particles can fade out at different times. From here, the particles should now fade just as expected. Additionally, we'd want the particles to rotate over its lifetime. However, this can be as simple as enabling the Rotation over Lifetimes tab, as the default settings will suffice. Head back to the top and switch off looping. Now from here, you can duplicate this asset and make additional changes. It's up to you. The one I used here tweaked the shape of the emission into a donut, rotating upon its x-axis by 90 degrees and scaling it to fit inside the box. From here, you can alter the spread of the emission to be centered along the equator of the box so that the particles can emit much more heavily in this direction. Additionally, I created another particle material which utilized a spark map, but you can use the default diffuse map as the alternative. Essentially, this material is a duplicated shrine particle with a different map. Lastly, change the burst to 250 so that there can be a lower particle count. For the glow effect, this is where post-processing comes in. Now, I won't go over the many areas of post-processing as it's not important in this demo. Firstly, make an empty game object, then switch on the post-processing stack on the camera. Then head back into the empty game object and then add a component named volume. Once that is added, make a new profile, add override, then add in the bloom effect. Then set the threshold to 2.2, the intensity to 1.5, and the scatter to 0.4. From there, a brilliant glow will emanate from the particles during emission, closely aligning to what we see in Breath of the Wild. And from there you have it, a near facsimile of the shrine particles that we see whenever we get an orb. From here, you can make further modifications. Now, we will experiment with particle system force fields. Now, particle system force fields are basically components that influences the forces associated with these particles. These force fields can have many uses, but what we will be making is a simple attractor. Now, I've prepared some particles with a trial material. However, simple default particles can also demonstrate this too. Now, what we want is for the force field to modify the forces of the particle that direct it to a single point. Firstly, we will create an empty game object called particle attractor, then attach the particle system force field component. Then, in the particle system, enable the external forces tab so that the force field can have any influence on the particles. And you might want to also check on the layer mask if necessary. From here, the effect would occur immediately, and with gizmos enabled alongside extending the end range far enough, The particles will begin to fall towards the center of the attractor once in the sphere of influence. Thus, you've now made a simple attractor. From here, you can perform whatever modification to the attractor. For me, I'd want these particles to orbit around the attractor's center. In the force fields component, under the rotation header, increase the speed above 10 and set the attraction to 1, and just like that, you've got yourself orbiting particles. If you'd like, you can play around with the setting to get different behaviors between your particles and the force fields. It's up to you. From here, you should have a knowledge on utilizing particles. Unity's particle system is a powerful and versatile system that can be utilized for different means. From this demo, it should offer some insight to what you can make in Unity's particle system, allowing for creations for more dynamic particles for your games. Thanks for watching.